I say like, if you can produce on a daily basis 25 kg of organic waste, you should not go to direct composting because you are losing on the energy part. So always install an anaerobic digester, which is, going to give you the biogas also, which you can use for lighting, I won't say electricity generation, but you can at least light, the biogas lamps you get. Those are like menthol lamps, okay? And second is that you're getting bioslurry, which has got a solid part and a liquid part. Both are applicable for, organic, both are applicable for promotion of organic farming. Okay, now see here I have shown that every state, Biogas Development and Training Center, they're responsible for all the states. I'm responsible for, BDTCIT Guwahati is responsible for all the 8 states. And we're also responsible for West Bengal. But this scheme can be successful only if all the state nodal project implementing agencies cooperate with us. Okay, I'll show you. Like they each one of them have a huge number of targets. Each year they get, and I'm sad to say that this year, I'm yet to receive the annual report from them. From there, I'll come to know how much has been achieved. But majority, maybe I think 60–70% will be returned to the ministry without spending. Okay, so I'll discuss about the issues that I came to know from them. So it is, I think, without, you will be the connecting links. All the NGOs can be the connecting links, and the municipalities can be the connecting links for making this project successful. Because we are looking only from one direction. Villagers, whether they have cattle or not, if yes, okay, let us give them a biogas technology. Or maybe we are targeting only the dairy farms. Okay, and as and when, if they approach us. Okay, so this is where everybody can contribute. Now, briefly about the technology, as I said, all the organic waste be generated in the kitchen, community kitchen or household level. The animal waste, dairy farms, piggery, poultry, the community kitchen, though that schools that we have kitchen, public, this one, feeding, and at community level, the agricultural waste. Okay. If you are dealing with such type of waste, then biogas technology can be a solution for addressing it, for energy generation, for bioslurry, for electricity. Okay. And as I said, if you can generate 25 kg of organic waste on a daily basis, please do not go for composting directly. You can install, MNRE has a scheme from 1 meter cube, but you can downsize it also, maybe 0.5 meter cube also. At every household can have it. Okay, so we can some ideas keep coming, and that's why being in an engineering institute, I have the I can design it and implement it. So if this, so just now while discussing, or somebody like question that cannot it be addressed at the individual level, I think it can be. We just have to downsize the reactors. We should not target on biogas production, but maybe like every morning we get the milk bottles delivered or milk packets delivered at our doorstep. Similarly, such type of systems or implementation of such type of systems, we can, if NGOs are involved, we can, from each doorstep, they can collect, packets of biogas and packets of solid organic waste and packets of liquid organic waste and give something in return. Maybe the profit, 1% of the profit. Okay, that is possible. Okay, so as we all know, I'm not going to go into much detail, that biogas has importance because it is about 50 to 75% methane, which is easily inflammable for heat, for cooking, which can be used for cooking, for lighting. As I said, you get biogas burners, and it has the unwanted portion is carbon dioxide. But now, like government is giving importance to bio-CNG. I'm not talking about that pipeline bio-CNG. Decentralized bio-CNG, this is on a huge scale. That carbon dioxide that you separate, you can also sell it. But that is for industrial level. I'm not talking about household or community level. Okay. Okay, this is, can I play it? Video, it's a video. Now I'm just, okay, it burns in a blue flame. This is this one, in dhaba, from the food waste. No, this one. Okay. See, this is biogas burning. This is from the food waste, from the biogas digester, which is installed in a dhaba. Okay. And you can just show the other also. It has a. This is, yeah. So this is the raw biogas without any cleaning, which you can use directly for cooking purpose. And let me just compare it with petrol. Like it is said that usually we do not get 70% of methane. Usually it's 55 to 60% of methane. So say it is 0.5 or 0.4 equivalent to 0.5 liter of petrol. Here it is, theoretically, it is said 1.7 kilowatt hour. Let's say it is 1 kilowatt hour of electricity. Get it? So this is from kettle shed to kitchen. So this lady, she has, she has kettle. So we install a 2 meter cube biogas digester. And this is in Amlikhat. It's a Nepali community. They rear kettle. You know, they have all the people from Assam, Hita Jokhala, you must have heard about it, right? So this is, they contribute their milk production to, that's a cooperative to there. Okay. Now, as I said, depending on first is the resource. That is the substrate, which we call in scientific term. If you have the organic waste, if you can generate 25 kg of organic waste, and if you have, number of animal required, although it is at 2 to 3, so better to have 4 cattle. If not 4 cattle, at least 2 cattle and maybe whatever you generate, organic waste you generate. Okay. But the minimum quantity will require to run a 1 meter cube biogas digester is 25 meter cube. That will be sufficient for cooking the meals of 2 to 3, a family consisting of 2 to 3 members. Similarly, you can, depending on your organic material, and depending on a requirement, you can increase the capacity of a biogas plant. Now, all the project implementing agencies that I showed, and BDTC IIT, like till 2021, only project implementing designated state nodal project implementing agencies had the received the targets to install biogas digesters. But since last year, even BDTC got a target of to install 100 biogas digesters. Get it? So like yeah, I'm going to discuss something later on. But yeah. But we are able to install only 40 as of now. That is, and that also only in Assam. I tried, contacting Meghalaya, Manipur. They are trying on their own because Manipur, this is the first time Manipur is becoming active installation of biogas digesters after this incidents that took place recently. Even Arunachal Pradesh, APEDA is responsible for Arunachal Pradesh. I think they procured around 200 numbers of prefabricated biogas plants. I discussed with somebody, just talk to them where they have installed these biogas plants. Similarly, each state has it, but it is very difficult. Tripura is doing very well. Sikkim was doing well, but has become non-functional. Nagaland is saying they do not have cattle population. Okay, we have to think about the toilet-linked biogas plants and those hostel or maybe kitchen waste biogas plants for Mizoram, for Nagaland, or because they say that during that Christmas season, the cattle population comes down, the pig population comes down. Okay, I think this is a fact. So that it's better to, in these states, it will be better if we go for the toilet-linked biogas plants, or maybe the organic waste biogas, the kitchen waste biogas plants. So this is it. This is a simple how it works. As I said, daily feed required is 25 kg. Now, suppose I construct a 1 meter cube biogas plant, HRT, that is hydraulic retention time, is about 55 days. That means you can keep your organics. What is the time period you require for production of organic fertilizer, composting? 30 days? 40 days. Okay. So the entire, depending upon the temperature, right? So okay. So HRT for Northeast regions for the biogas digest is 55 days. Okay. Now, suppose I said we are installing 1 meter cube biogas digester. Daily feed requirement is 25 kg. But once a newly constructed biogas plant, they will have to feed 25 into 55, 1375 kg. That is only one-time feed on the first day. You feed it and you wait for the gas production to start. Once the gas production starts, you will need to feed on a daily basis 25 kg plus equal amount of water. So you will get, 1 meter cube of biogas digester regularly, provided it is a living system. If we starve ourselves, we cannot function. If we overfeed ourselves, we cannot function. That is true for biogas digesters also. So if your digester is underperforming, okay, so there are a few technical things which we need to do, which I'll discuss. You just need to check the pH. Just need to check, how much water, maybe you have diluted it too much. Okay, so equal amount of water, organic waste plus equal amount of water. That is the feed material you need to. Because please stop me if you do not understand. I can come back to you again. So I'm just going fast because I need to, I want to show you all the slides. Okay, so these are the different factors on which biogas yield or the biogas digester performance is dependent upon. Main is temperature. Arunachal may be higher altitude. It might not be possible, but there are other ways also. We can, as Sir showed, like even in IIT Guwahati, they are doing it on solar panels. Okay, they're installing solar panels. So you're circulating a phase change material. Okay, so this phase change material, they can maintain the temperature of the digester. Till 15 degrees centigrade, it can perform well. But if it goes down, I think it goes down to 4 degrees centigrade, right? Or minus 4 degrees centigrade. So like there we have to work out. But I think in Mizoram, in Manipur, in Tripura, in Meghalaya, Assam too, it's working very well. These states, it should work well. Even in Sikkim and Nagaland and Mizoram, it will work well. But only issue is that they do not have cattle population. So these are a few things. Basically, your pH and temperature that you need to maintain if it's underperforming. And maybe that some technical issues might come up, but BDTC IIT Guwahati, we have well-trained staff. Okay. Okay. So this is the thing, the slurry, the biogas slurry that comes out, that contains around 6% of total solid. This is a simplest system of separation of the solid from the liquid, which is designed by National Dairy Development Board. Okay, so the ministry is giving subsidy for this also, installation of this also, along with your biogas digester. I'll show you how much subsidy you will get if you do. Okay, so you all know that the slurry, the biogas slurry, okay, that has got high nutrient NPK value. Okay, that can be used as an organic fertilizer. And compared to, I don't know, I've got it in the literature, but this is not proven. Okay, apart from that, what we did, the solid part that came out from the biogas slurry, we mixed with clay to, make pot liners. In the nurseries, what they do, they use plastic bags, for transportation, for the sapling, transportation of sapling. So this idea was given to them that you can use such type of pot liners where you can transport your saplings. So this can be directly put into your wherever you want it. So if you this will mix with the soil, enrich the soil at the same time. So you can do away with the usage of plastic also. This is not done by us. It was by, the idea was obtained from somebody else, but that we said we implemented it for this slurry that came out, the solid portion that we separated from the biogas slurry. Okay, this is biogas slurry used for organic farming. Okay, this is a biogas to power, simplest unit that we install nearby IIT Guwahati. One issue or a challenge, I would say, of the implementation of a biogas plant is that on a daily basis, you need to devote 1 to 2 hours, or maybe 1 hour, because on a daily basis, you will need to feed the digester. Whatever comes out, you need not collect on a daily basis, but if you're using something, a can like that, maybe once a week, you need to empty that. Okay, so some manual labor is involved. So usually we target the lady of the house, okay, because she's usually she's in the house and she can, she's usually it's seen that lady of the house, they do it seriously, they take it seriously because they are saving on the LPG cylinders also. Okay, no doubt you get the LPG cylinder free of cost for the first time, but what about refilling it? Okay, if you are getting it free of cost, the lady of the house, if you can, educate them or make them aware how they can save, so they are going to adopt the technology. And if a linkage, market linkage can be done, where this whatever solid waste is generated, if that can be collected, or if they can use it for organic farming. A market had come up in IIT Guwahati, organic products, where potato, long time back, it's no more there. Rupees 80 on one side, we were getting per kg potatoes. On the other side, we were getting 10 kg per kg, 10 rupees potatoes. So obviously, we checked out the whatever vegetables were available, but rupees 80 per kg organic potato is not feasible for us. But if that same, by using the small amount of organic waste, a long time back, our ex-Prime Minister Lal Bahadur Shastri, used to, I remember my father, like he used to say, he encouraged, you should only generate our own, that kitchen garden we should maintain, generate our own vegetable garden and all. So if such type of things we can, encourage the lady, the villagers and all. On a community level also, we can do that. So this is the lamp that I'm talking about. But if you check on Amazon or somewhere, you'll see that we do not have this lamp. The marketing of this lamp is not much. This can be a product for, this can be taken up. This is like the mantle lamp only. Okay, but mantle lamp, what you do? You put kerosene and you pressurize it. Here, it's already gas, methane gas only. Okay, you just need a flicker. Okay, there's a switch, just need to flick it so that that methane, it gets inflamed and it burns. This is the mantle is there. So this easily, that biogas digester that we have installed at individual level for cooking, for organic manure, at night can also be used for lighting without generator. If an MNR is trying for promotion of toilet link, but not possible, it has not been feasible. But Nagaland and Mizoram, I hope they will come up. Since they do not have, as I say, shortage of cattle, so maybe we can encourage them to take up the biogas technology and to link it with toilets, maybe in hostel sites, maybe official or wherever. Or maybe this mixed with, that market waste or something feasible we can come up.
It should be planned previously or it can be implemented?
It can be implemented just like that. We have the technology, we have the everything. We have everything. We just need to call us. That's what I'm going to tell. So at individual level also we can do. And this is something to show that during the production of biogas, it from the raw organic waste to the methane generation, it goes through 4 different steps. So if a chemical engineer is sitting here, he will come to know that each step will give you a value-added product. So this is not for this platform. Maybe if you want to, go for an industry, chemical industry, we can, they are doing it. Okay, so main objective is what? We need clean cooking fuel, lighting, with thermal and power requirement, obviously greenhouse gas reduction, women empowerment, and organic enriched biomanure. Okay, let me come to this. You can see all the states here, right? So this is the targets for installation of small biogas plants, 2 to 4 meter cube. Oh, this is 1 meter cube, 25 meter cube, okay. From 23-24, you see all the states. If you see Arunachal Pradesh, APEDA is there, Assam, Forest Department of Assam is there. Then you come to Meghalaya, MN Redda is there, Mizoram, I think Director of Animal and Agriculture and Veterinary, Nagaland, the Department of New and Renewable Energy, Sikkim Shredda is there, with, I think all this, no? Okay. Just that it's bold, in capital bold, the number of plants they were to be installed. So you can approach them and tell about your requirement, that we have this requirement and funds come to them, okay? And the main thing is that, okay, if you want to know about the implementation, okay. See, okay, maybe next slides will make it clear. Okay, and this is the subsidy you get. For northeastern regions, if you install a 1 meter cube, it's going to cost you around 25,000. So you are going to get 17,000 back. If you're going for a 2 to 4 meter cube, that's going to cost around 35,000, but that's going to give you back 22,000 subsidy. Okay, so this subsidy, how to avail this subsidy, I'm going to tell you. See, additionally, if you if you link your biogas plant with a toilet, additional 1,600 subsidy you'll get. If you install that biogas slurry unit that I showed you, we'll get an additional 1,600 subsidy. And turnkey job fee, that is, turnkey job fee is this one, like, you'll come to know in the next slide. Okay, this is for the power generation. So if you go for 3 kilowatt to 50 kilowatt, this is the subsidy that you get. Power, thermal, okay, and this is the administrative charges. Administrative charges is for us, but I'm ready to give it to you. If you can implement, I can channelize to you also. It's come to us, it's no, because we cannot, because it does not, see, we are government salaried people, okay, but there are institutions which are only dependent on such type of activities. We draw salary at the end of the month, so we are not into business, okay? So there is a government policy. Although this administrative charges we will get aram say if we give project completion report. This will come to us, okay, which we can use for our own personality development. But I think that so much is not required for personality development. Okay, so that can come to you, but I can just share with you how it can be done. Okay, now what we can do, BDTC, what it can do. We can train skilled masons, okay? If you have in your community, if you have people who have machinery expertise, we can organize trainings for them so that they get training for construction of biogas plant scientifically, so that whatever biogas plant they construct is going to function properly, okay? There won't be any discrepancy. So for getting that training also, they get paid. We are going to pay them 450 rupees per day. So the training period is from 1 week to 10 days. For each day, they are going to get 450 rupees, okay? So during that training, if you all identify one family who has cattle and who takes the responsibility to run this biogas plant, we are going to construct a biogas plant for them free of cost. During that construction only, these 10 other masons will get the training, okay? And then they will replicate for others. After that, it will come at a cost. After that, the beneficiary has to pay and then can avail the subsidy. But the first, because we get targets, as I showed you, we got target of 8 CCM trainings this year, okay? But since it started late, it got reduced to 4. We already gave 4 CCM trainings, okay? So during each CCM training, we trained 10 more masons, okay? We give certificates to them. Now, whether it be MNRE, whether it be that under the Govardhan scheme, wherever, if there is any call for biogas construction, these masons can participate, okay? Second is a turnkey worker. Anybody here sitting here can be a turnkey worker. Okay. Suppose Javed comes to me. Okay. I'm just okay. I'm training him as a turnkey worker. I'll give him a certificate. Now there is a tender call from say government of Manipur that we require installation of 1,000 biogas plants. Javed can participate in that. Okay. So Javed can participate in that. He will get the remuneration, whatever he'll get that tender, when you have to submit quotation. So that is your call. Then you will have missions under you. You complete your task. You submit the completion this one report to us. We forward it to the ministry. You get the subsidy, and whatever fee it is, you will get the fee. So this is the turnkey workers. Apart from them, we do staff training, we do users awareness training, we do refreshers course, and since last year, we have been getting targets also for installation. Okay. Now, if any state approaches BDTC IIT Guwahati, stating that we have this many targets, okay, so provided we get the target, because this financial year is over. Now we wait for the next sanction. Hopefully it will come soon this year. So we can start work immediately. I'm going fast. Other activities, as I said, we do testing also. If you come with a new type of digester, we are going to test it for you, okay? And we are going to submit the report to MNRE. And MNRE is going to, if it gets approved, then all to get the subsidy, you have to install the MNRE approved designs. We do some time, because I belong to, I'm a part of IIT Guwahati also, so I have to do some portion of, or devote my time, a portion of my time for research activities also. Okay, I'll show you a few designs that we did. So these are the different types of biogas plants available. All are not MNRE approved. So if these are not MNRE approved, you cannot install it. But these, okay, I'll just show you. This is a fixed dome type. This requires civil work. I'll show you. See, this requires civil work. Here's the trained mission. Okay. First, you want a pit. So for 1 meter cube, you require 6 feet by 18 feet. No, 8 feet by 16 feet. 8 feet by 16 feet. So this is a 1 meter, 2 meter cube he is constructing. This is prefabricated one, which you just fabricate outside, and then like prefabricated those constructions that you get, something like that. Okay. So this is a mobile down. As and when your gas production is there, the drum goes up. As when your gas production is low, the drum goes down. Okay. But these are still, although these drums are made of steel, construction cost is high, and there is a chance of corrosion. So best, and see, this is and best we as of we encourage installation of your fixed dome digester, because that is underground. Since this process is temperature related, so if you keep it underground, the temperature variation is not much. That 8 to 10 degree, whatever, that's going to sustain the technology. So this is a prefabricated one, newly installed, okay, subject to mechanical damage, but I'm not saying it's bad. But this has to be on field for a few years to actually know how it performs. So as of now, there are 6 players for prefabricated ones, which are recognized by MNRE. If you install these, then also you're going to get subsidy, but these are the cost is slightly higher. People are having difficulty paying 25,000. So imagine paying 42,000 or 40,000. So these are storage bags. Even if where you want to use it, the location where you want to use it do not have cattle population, so you can, carry your biogas to the site of utilization by, storing it in such bags. These are easily available in the market nowadays. So this was something I was discussing with sir, that at individual level, the same digester design, it is nothing. Input, the digester, the output. If we are targeting our organic waste, just put a shredder, just put your daily organic waste, just, shred it. It'll come down. It'll be there. Okay. Whatever gas comes out will get collected in something of a smaller dimension. Okay. And whatever comes out, we fix something which I showed you on a bigger scale that will get collected there. So as and when, say, it takes, we have an idea how much waste we generate. Okay, once it is full, okay, to some that how much, it inflates. We can keep it. Then if somebody comes and collects it from us, these are smallest at smaller level. In fact, the manure also, somebody collects from us. That way, your lady of the house can get some income. It can serve as a source of income for her. This is just an idea. It's not. There's some big ideas keep coming because I'm into this thing for quite some time. Okay, these are the different name of the developers. 6 developers have been recognized by MNRE. This is prefabricated ones. Cost is slightly higher, but you all can try. So that these are glimpses of the activity. This is in West Bengal. They installed 50 kilowatt digester. It's a dairy farm. And the total cost was around 70 lakhs. But the financial assistance, central financial assistance, that is 15 lakhs they are going to get. This is in West Bengal. Another one we did is from biogas to power is Rian Farms in K3. This is a piggery. They are using piggery waste. It's a zero waste facility. Whatever piggery waste comes, they put into this digester. In fact, after that, they have a screw press. This year, it's not very clear. There's a screw press. So they separate the solid part and separate the liquid part. The liquid they recirculate again and put in the digester. Because for biogas digesters to function, 1:1 ratio, you have to mix water also with water also, okay? So, and the organic waste that's generated, they are distributing to the villages free of cost. And this they are using for generation of electricity. As you can see, this one. So this is the prefabricated digester. So these are the recent snapshots of, awareness training programs that we conducted. This is again, somewhere in West Bengal, we constructed, construction cum maintenance training. If you can avail the construction cum maintenance training, you will be at a profit because you are going to get one digester free of cost. Plus you are going to get, the 10 machines along with you. Plus there will be an RET also. Everything will be at your disposal free of cost. You just need to, book this one, that for lodging, you just need to book, we are going to pay. And this comes directly from the ministry. These are recent snapshots of new installations of biogas digesters. The new installations, these are some airport authority we trained. This is the vermicompost unit we had. Okay, this is some small research facility because that I showed that biogas contains H2S also, which is corrosive. In village, that kolakhar we say, the banana peel, we burn it, right? That is highly alkaline. So what we suggested, you just put it in a pipe, kolakhar just put it in a pipe, and before fixing it to your burner, just interface it along with your digester and your burner. So whatever H2S and whatever your CO2 is generated, that will be reduced and your stuffs will be saved from corrosion. These are simple tricks we give them. Okay, this is something for which we recently got a patent. We hybridized the fuel cell technology with biogas, and we could enhance the methane content of biogas. Okay, and this is a very wild idea I had, like during that Corona period. This idea what to do, we were sitting at home within the campus. We just use, what's that called? Graphite plate. One graphite plate. To that, we just layered, that cow dung. Because cow dung contains what? Organic waste. But organic content it contains, plus it contains microbes. Oh, that's fuel. That's a battery, biobattery. Biobattery we fabricated using cow dung. And that, yes, but that fuel cell, you need to have your catalyst. Say, suppose you fill with methanol or fill with, say, hydrogen, you will need the platinum catalyst, which is high cost. But here, the waste we are using, maybe any waste, any type of waste, you can, you can use glucose. So this is a single unit. So if you stack it, but for a biological system to run successfully for power generation. That's what I must say. You require a power management system. And this small amount of electricity that it's generating is enough, to maintain the temperature of your digester. That in higher places we said, no? Okay, so this is a vermicomposting plant and this is a vermicompost for sale. So I went very fast, very want to come back, and please, I'm open for questions. Am I on, what's the time? Do I have time? No. Yes, sir. Oh. Huh? Oh, that everything design and all, everything I'll share with you. By heart, I do not have it. Yeah. For flood affected area, that's like Majuli, no? Flood affected area. There, we can try the prefabricated ones.
Okay.
That there we need not do deep construct. Yes. As and when it comes, you can, you can release the gas production. You can release the gas, fold it and keep it.
Okay.
And again, reinstall
Because
it.
in my village also water level is very high.
Yeah.
So
no,
like-
it'll be that will be feasible for Majuli.
okay.
That will be feasible.
Okay. Thanks.
Yes. This one is just research thing. Actually, what happened? I hybridized anaerobic digestion with fuel cell. Actually, what happens? The anaerobic digest, the anode, the biodigester, it's anaerobic, and the anodic chamber of your fuel cell is also anaerobic. So what I did, I just hybridized it.
Okay.
So that your cow dung has methanogens as well as electrogens. Okay, so these electrogens, they oxidize organic waste to protons and electrons. On the other hand, methanogens, they produce methane and CO2. So this CO2, binds with your protons and electrons, and again gives you methane. So this is how it,
Okay. Can you click this one?
We have it. That's two questions, no other question for her, because you are here. Let's get up with her.
No, you have to contact me. Otherwise, this scheme is not going to.
Thank you, ma'am. It was a very impressive presentation. I have so many questions, but I'll ask only two, as said. So I just wanted to see, we have an FSTP in Shillong.
Yeah.
So till now we are planning to use that fecal sludge that is used, so that we are taking from the dry beds after recycle, after treated. So can this cow dung be used, or can this sludge be used instead of cow dung?
Anything organic can be used for biogas production. The solid content has to be between 8 to 10%.
And
Anything, it can be done.
okay, I'll get back to you personally
Yes,
for this.
I want you to get back to me.
Yes.
please.
And regarding this, one more thing is that I just want to.
I'm very thankful to Atin sir and Kaifi, really.
Yes.
Please
I
help.
just wanted to know the commercial viability of this.
Pardon?
Commercial viability is the.
Commercial viability, yes, that's actually commercial viability means if you are trying to sell biogas or what, then you have to package it and sell it like LPG cylinders. Or maybe if you want to sell it, you can save on electricity. Then whatever manure comes out, that's two portion, one solid and a liquid portion. That also you can package and sell it separately. Yeah, it can be stored, packaged and transferred.
Yeah, last question.
Hello, ma'am. I have two questions. Primarily, my question is in the composition of biogas. In the diagram, you showed us that 75% of it is methane. A certain amount of it is carbon dioxide as well. So upon after combustion, do we have some effluent carbon dioxide which gets emitted after combustion?
This is, organic carbon.
Okay.
So this whatever, this was what that cow dung, that whatever green plants the cattle had. Okay. So from there, whatever CO2 was, from during photosynthesis, whatever it was trapped. Okay, that got released. So again, that only gets it the recirculated green carbon CO2. That's not adding to the footprint.
That's it's not harmful for the human consumption or animal consumption. The second question is, ma'am, we have understood from certain power generation companies like Kirloskar, Cummins, that they have power generators which run on natural gas. So for biogas, is it having the same calorific value and composition as natural gas? Okay. Okay. Okay.
Just advisable to verify because the emissions content and the generators.
Okay. Okay. Great. Thank you, ma'am.
अपना लैपटॉप यूज करना है
Thank you, ma'am.
तो वो नहीं होता है वो लाइव स्ट्रीम में जाएगा
नहीं वो उस पे चल रहा है साइड में हूँ
चलो अभी
Just go there once and see if you can find the answer because it's a PowerPoint picture. It will be there in regardless of what finding.
कैफी
एक बार सर पे वाली है ना he wants to draw certain things
पॉइंटर राइट
Not only I, when I want to show my other content also, I can show them. That is the whole thing. But whenever I do, so many things.
So thank you so much, Lipakshi ma'am. It was a great presentation, lot of insights. Just a quick information. We have a portable biogas plant here in ATI, right behind the cafeteria. So like we did a hiking in the morning, this morning, since time-wise, we are way behind the schedule. So I will request Kefi, we have a composting unit. It's fully decentralized, nature-based, which is in the back of the campus, right next to the gym. And the biodigester is here. I would request Lipakshi ma'am and Kefi to take the participants, at least those who are interested to see it, because we are using it here. So we are using our own food waste that we are producing in the kitchen as a feedstock to the biodigester. And you can see the burner. It is being used for heating water, making teas and coffees. So that way we are also saving a lot of LPG. Right? So a household which is using a biodigester based on only household waste can save as much as 2 LPG cylinders a year. That's not a small amount. And then your waste problem is solved. At least the wet waste part is solved right there. Right? It's a fantastic nature-based. It's a gift of the nature. And like I told you yesterday, like imagine if the wet waste doesn't have to be given to the collector. Our scenario will be very different from what it is today. Yeah, Kefi? Just make a note and we can schedule a time towards the closer of today's session. Like what time, because it's right behind cafeteria. So you have to just walk, 40, 50 meters to go there.
Because ma'am has already covered about everything, like every aspect of the biogas. So we also wanted ma'am to while demonstrating, so she can actually explain and she can also talk about what kind of
because now you have heard the theoretical part, the working principle, feedstock and all the rest of it. There you can see it live. See, it's a live demonstration of what she has presented.
You can also
in a miniature form.
Can also relate with our challenges as well, what we are encountering and how you can also actually resolve it while you are planning for your biogas plant. So it would be really very, very helpful when we'll actually go for the demonstration in the next day.
So Thank you, Lipshika ma'am, for such a nice presentation. Now, for the next presentation, I would like to invite Professor Umesh Mishra, sir. He's a professor at NIT Agartala, and he has over 39 years of research experience and have over 50 research publication, and several book chapters. And his main research area include water and wastewater treatment, municipal solid waste management, and air pollution. So I'll hand over the stage to you, sir.
My dear participants to this municipal solid waste circular economy conclave in namely Rajasthan. And I thank organizers to give me an opportunity. Best. ये ठीक है? Okay. I thank organizers for arranging a beautiful conclave and beautiful gathering of all the Northeast states, a networking of urban local bodies and teaching organizations, as well as NGOs. So this entire combination, I think it will give a good progress in the area of solid waste management for coming years to come. And I also got invitations previously, because for such far distance it was coming very difficult, because it was Northeast, not required. No. Northeast to come here is also quite difficult. Anyhow, and I got the invitation, I think, on CAF. Javed has given on 18th March. And that time I was moving to IIM Bangalore for my leadership, academic leadership program. So it was a 9 days program from 24 to 30. I was there that time. So I could not discuss with him. He was telephoning, I was not responding actually. And the topic he has given, I have no knowledge on that topic, frankly speaking. This is actually, we are old people and our topics are very old. And this, the conclave they are doing in a very new area. And may I ask, how many of you know what is circular economy? Please raise your hands. Exactly. Good. Very good. But I didn't know. Okay. So I thought, okay, anything I can read and I will be able to understand. So, but when I completed my IIM Bangalore program, I came to know that I have got election duty. So to make pursuance in the exemption from the election duty, these 2 days are gone. I came on 30th, 31, 1. I came on 2. So I didn't get time to what to prepare. So yesterday, what happened? There was an issue. We are having a very good garden. If possible, I can show you. And we have spent about 30 lakhs in the campus. There was 10 quarters were there. So initially, Padma Shri Nana Patekar came to inaugurate that building complex, and he has given the first occupant of that building. And remaining 9 quarters were vacant. And just when we have taken, my missus has got a passion for gardening. So she started gardening. And initially, what was the problem? There is a water pump problem has started. That means all the 10 quarters are 2 overhead tanks. So total 20 overhead tanks. and water is coming directly from the 200 feet groundwater, and it is coming to the swamp well. From swamp well, there is a 10 HP, that is another 10 HP. That is 10 HP submersible, and this is 10 HP centrifugal. And, and we are only the user, but the remaining 18 tanks are always full. No user is there. So what is the solution? People will tell float valve. Okay. The engineers told, if you will put float valve, then it will burst, because only you will be the user, and 10 HP pump is carrying a lot of water with high speed. What is the solution? So they told that at least you keep 4-5 houses open, waste. And this is the advice. Okay. And at least one bulk, one open. So there are 2 tanks, one tank for internal use, 1000 liters, other one is 500 liters. So in that 500 liter, till our tank to be filled, all 18, all by 5, 6 has to be wasted. Then Mrs. thought, so why should we waste? Let us go for gardening. So we started gardening in other houses, because nobody is coming, because 18,000 house rent allowance is available. That time, the HRA is in the level of professor, it is 18,000. So why people will come inside the campus and pay 18,000 rupees? So she started initially some gardening. Okay. After that, the appoint a gardener whom we are paying about initially 10,000, next year 11,000, next year 12,000, now 14,000 he's taking. So in this process, for collection of seedlings, for collection of gobar, that cow dung and all these things, on an average, we are spending 50,000 on that. So total till now in 6-7 years, it is now a very good garden. And because people are staying outside, after seeing the garden, people started coming. It is attracted them. So this was the thing. So yesterday night, what happened? The gardener's wife died. Okay. So when I was preparing, so it was very, so that's why, please allow me at least to show what garden both of them, my wife and that gardener, has done. Please see that after the end of this. Yeah. This will be done. I actually could not prepare. Just I prepare something on circular economy. Pani do thoda. ठीक है. Okay. So actually topic was something else. क्या topic था? Let me read that. Eh? No, this is not the topic. My topic was something else. That also I didn't understand what is that. That is, where is Umesh Mishra? Challenges associated with circularity in the Northeast. But I have changed that. Please don't mind. Okay. So I have made it opportunities and challenges in implementation of circular economy in the Northeast. I think, Javed, it is correct or not? See. Hello. Okay. Okay. So earlier the economies they are telling linear economy, that they are telling, I think, छोटा वाला कहाँ है? Take, make, use, dispose. Okay, this was known as linear economy. And circular economy means we are reusing finally. Again, it will be a feed material for the process, and it is joining the life cycle analysis. LCA of the industry, it is coming. Okay. So, and also beyond. Now means, I think your the main circular economy is planning of Europe. What I studied yesterday, that refrigerator we purchase from that so and so company. So that company will give you the refrigerator lease for a period of 15 years. After 15 years, it will take back. So with some price, looking into the status of that. So that is where it is on lease. That is called real circular economy. Whatever I have gone through. Okay, so this is like this. So it is started from here to take, make or remake, distribute, reuse, selective, enrich, recycle, and so this is, that's why it is calling circular economy. So circular economy definition, as per the one NPTEL course I have gone through yesterday, an alternative to traditional linear economy, which is make, use, and dispose. So that what is linear economy is you make things, you use it and dispose it. In circular economy, resources are kept to be used as long as possible. Okay. That's we are shown circular. It is not 100% circular. 5-10% will go away. So that's why as long as is there in the definition, as long as possible, and extract the maximum value from them while in use, then recover, regenerate the products and materials at the end of each service life. And we are trying to recover the material, regenerate the product and material at the end of each service life. Circular economy is a restorative, regenerative by design, means that material constantly flow around the closed loop and is actually flowing in a closed loop, not going out of the loop. But this is not possible. Anyhow, then what will be the properties of circular economy? One is reusability. That is amount of material that can retain its functionality. Okay. Even we have used one fridge and after 20 years it is running as it is. There is no problem. So this is reusability is continuing. We cannot even go for circular, it is not required for us. Okay. So, so and its physical attributes, जो वहां पे जो प्रॉपर्टी था अभी भी वही है. And एंड ऑफ इट्स प्राइमरी लाइफ, मतलब जो फैशन की वजह से छोड़ देते हैं, अरे नया कंपनी आ गया, मशीन इधर दबाओ, ये फटाफट आया, वी आर टेकिंग, अदरवाइज मैकेनिकल सिस्टम इज स्टिल रनिंग. ओके. देन सेकंड इन रीमैन्युफैक्चरेबिलिटी. रीमैन्युफैक्चरेबिलिटी, कभी कभी देखे हुए लैपटॉप मिल रहा है रिफर्बिश्ड. ओके. दैट मीन्स that laptop was some little minor defect was there, but the person has given return to this Amazon, they have taken it, they have repaired it and they are selling it. And my son-in-law, he was in earlier in Qualcomm, now in DRDO. Just recently I have purchased the iPad in 40,000. Same iPad he has purchased in 12,000. He told that it is refurbished and he has seen the specifications, whatever his requirement is fitting. Okay, and I see, and they are telling the exact truth. I thought that वो तो मीच झूठ बोल रहा होगा. नहीं, whatever they are giving exactly right. So this is refurbished or remanufactured. Okay, then come to mass recyclability. How it is done? Potential to restore a component, product to like a new condition through measuring, de-assembly, cleaning, inspection, sorting, part repair, refurbishment, replacement of reassembly, final testing on weight basis or item basis. Item mean full or some weight, part of it. Then mass recyclability, amount of material collected and stored for recycling on weight basis, by weight. That means EA item is not coming electronic, non-electronic. This is fitting. Then mass recoverability. amount of material, proportion material component product that is captured after the end of use. Then energy recoverability. Energy embedded in the materials components and products part recovered waste to energy plants in the form of electricity and heat. Like some PCB, from PCB is that means particularly generally people are throwing desktops, but that can be used. Particularly in case of e-waste, that will give good livelihood if it can be. So as per US EPA, the circular economy is following types of materials: reuse, reduce, recycle. Another is replace. I think 4R is there nowadays. Okay. So as per United States Environmental Protection Agency says, we can recycle aluminum, particularly this aluminum cans, plastic, glass, steel, paper. Okay. So for battery about 99% lead-acid battery can be recycled. It is running, so it is already in circular economy from the beginning. So directly it is going back to company. So company वहां पे लिखता है आपका 6 महीना हुआ है, 2 महीने, 2 साल हुआ, 1 साल हुआ, 4 साल हुआ, 5 साल हुआ, जो भी है वो लेगा. 500 पे लेगा, 300 पे लेगा, 4000 लेगा, डिपेंड करता है कितना लेगा. So it is already in circular economy. I think this concept, if I will tell, so they are separating lead separate, acid separate, plastic separate. तीनों को separate करके they are doing. So this is directly the photo from US EPA. निकल कैडमियम है, ज्यादा हो जाएगा मैं कहने, और lithium is also there. EV battery is there. So battery category will take your 15 minutes. So that's lead. Battery has a very category. Like battery you are using in the in your घड़ी में जो use करते हैं वो भी battery है. So this battery is largely used. माने in your car, माने running car, petrol car. I am not telling electric car. Okay. So this is the next is steel. Steel is already in circular economy. Steel is the best. 100, almost 99% is recycled. Karo, and it will come back. So यहाँ directly वो लोहार iron जो बार हो जाते हैं, mild steel बार directly हो जाता है, कोई problem नहीं है. Then, so, and this is like, there is a बांग्लादेश में एक स्टील कंपनी है, इसका काम है by ship in Chittagong. We visited that. Bangladesh is just border to our place. It is only 4 kilometers away. International border is 4 kilometers from Agartala. So we went there in Chittagong plant. That name is BSRM, Bangladesh Steel Rolling Mills. What they're doing? They are purchasing abandoned cars from Europe, UK like that, and entirely they are melting it and finding the whatever the resource recovery as a metals, they are converting it to steel rods. That, and they are selling in Agartala. That is cheaper than Indian my steel rods. Okay, so that's why this car picture I have given. Then come to e-waste. If you go for e-waste, what are the types of e-waste? First one is your gadgets. That is, we can call large household appliance, refrigerator, washing machine, etc. TV, big size, or simple household appliances like table lamp, IT equipment like computer, laptop, consumer electronics, then lamps and luminaries, toys, tools, medical devices, monitoring control instruments, automatic dispensers, etc. These are the types. Then what are the benefits we will get if we can go for e-waste? Okay, that will IT prioritize environmental protections. It will create jobs it increases the affordability. E-waste recycling helps reduce air pollution. Electronic recycling promotes soil fertility and maintain nutrient. E-waste recycling helps to conserve available natural resources, solves landfill, and reduces the gas GHG emissions. Prevent water bodies from toxic waste processing, promotes fisheries resources, encourage mindful consumerism and awareness. Okay, so that means in this one point is there. Here it is reuse, refurbishing is going to directly sell after slight repair. Okay. Then come to reusability of C&D waste. In the C&D waste, the first three items, that is brick, concrete block. These three can be used as a road aggregate. If you are going to use it mostly, and it is this is collected after dismantling the building, or directly it is demolition, renovation, and also from new constructions. Second, asphaltic pavement, that is from your parking areas, and it can be used for as a new asphalt. And metals and ferrous, structural and framing steel, just steel scrap that just we are discussing now. Non-metals, that is aluminum, copper, brass, alloys, electric plumbing, etc. That is in the scrap market, particularly Kabadiwala, they takes. And wood, if it is a complete wood, that can be used. Otherwise, it can be used as a fuel, firewood fuel. Wood flooring also can be used as a fuel. And gypsum wallboards, that can be also used as a powder and soil amendment. And ceiling tiles, that can be used as a sometimes this can be used for the repair of the tiles. And porcelain fixtures, that can be ground and that can be prepared as a aggregate. Then recycling of textile waste, textile sorting, then textile fiber preparation. From that, filament will be, and from that, yarn and new textiles can be recycled. Then come to plastic. So plastic categories are PET bottles, that is polyethylene terephthalate, high density polyethylene, polyvinyl chloride, low density polyethylene, that is actually carry bags. And this PVC is PVC pipes and floorings. And polypropylene, particularly medicine bottles, special type of bottles. Polystyrene, that is packaging for tea, cups, ice cream. And others are thermoset plastics, etc. And these are the list, and these I'm skipping this. And how the plastic waste affect those, particularly breeding of mosquito and all these things. Everybody knows the plastic waste every time we are discussing all these things. Then how we can separate it. The sorting is done using hydrocyclones. And if it is small size, then that can be used using these conical cyclones, and cylindrical cyclones are used for mixed type of feed. And this is the sorting machines. And magnetic method is used for the sorting. And we can collect by different methods: mechanical recycling, feedstock recycling, energy recovery, and landfill is the categories. Under mechanical recycling, that is palletizing, extrusion, inject molding, drawing and shredding is the total process. For feedstocks recycling, pyrolysis, gasification, waste to foil. And for energy recovery, directly incineration and co-incineration. And last one is, if you are not doing remaining whatever is there, you send it to landfill. So recycling is the process in which discarded waste is recovered or reclaimed, reprocessed, refined, or yield altered new products. Recycling of plastic mainly depend on the resin code plastic waste. Top priority of waste management has always been recycling. It's not only help us in protecting the health of the environment, but it also contributes to reuse the waste productivity. Thereby, it takes the space in the landfill. Then mechanical, these are the process in the mechanical landfill, and finally we are pelletizing. Okay, and these are the different process in which we can collect the collection, as well as different type of material we can collect, make it some textiles. We can make also bottles. Also, again, we can use some higher quality of poly bags. So, besides that, we can go for pyrolysis. In the pyrolysis, we can collect some fuel, and also it can be used for this permits the unwashed and soiled plastic. This is greenhouse films repair, and this recycling plastic laminates extrusion and multi-layer packaging films, particularly those with aluminum foil layers that are difficult to recycle, and direct incineration, in which that will generate waste to energy system. And so there is some advantages there, and the disadvantage is there because it is plastic, so toxic gases may come. And plastic also can be used in the roads. These are plastic roads. In particularly, it is mixed with the aggregate, and it can be used as a poly-coated aggregate. So it has got good capability. So the procedure is like that: first cleaning, then shredding, then heating, then mixing. Okay. Then in this, strength increases by 100%, no potholes, and a beautiful road can be constructed. And is the best, and entire plastic will be consumed if you will use for the roads. Our Honorable Minister Nitin Gadkari, jitna road bana raha hai na, sara consume ho jayega. There is no problem with plastic at all, if it will be accepted. Already there is a Ministry of Transport, Surface Transport has given an order. And in particularly in Uttarakhand, first it was started in Uttarakhand. After Uttarakhand, it is accepted by Government of India. It can be totally used. It can be substituted in the bitumen. You can use it directly in the aggregate, so that it will be there. And this will never make any pollution. So all these marine problem, it is creating problem to the animals, everything will be gone. Best solution is roads. Any infrastructure. Microplastic for taking in the food. Microplastic has nothing to vehicles. हाँ होगा, लेकिन तुम तो उसको you are not taking why we are changing this? Because your plastic bottles may contain microplastic, and I think इतना नहीं आ रहा है जितना पॉलिटिक्स हो रहा है. ओके क्योंकि प्लास्टिक का कंफर्ट दुनिया में कोई नहीं देगा. प्लास्टिक बोतल का जो कंफर्ट है, अब ये बोतल ये ऑल यूजलेस. माने यू नीड ए स्पेस. प्लास्टिक बोतल जेब में डाल के इतना छोटा ले जाओ, जहां पे पानी चाहिए पी लो, ये उसकी वजह से जेब में इसको डाल सकते हो क्या? So this is the advantage. Strength increases, no potholes, no rotting, withstand heavy load, decreases bitumen consumption, and construction cost reduce, value addition, waste plastic, nil maintenance for 7 years, no effect, radiation like UV, life of the road doubled. Okay. So advantage is plastic is a good binder. Plastic improve the aggregate impact value. Plastic will increase the melting point of the bitumen. It helps improve the quality of flexible pavements. Okay. But there is some limitation is there in collection. Again, you have to make some segregation is there. It's not so easy, but 90% you can use it. This is the best combination. Then some people have used, you can use the entire thing. This is the comparison. This is the comparison with normal road and कट रहा है क्यों? वो तो मेरा कटता नहीं anyhow. ठीक है, this is the comparison. This is bitumen road, plastic tar road, and the resin. Okay. Skid resistance, sand texture, roughness, Benkelman bin, density, all these are well in. Okay. So density is better here. It's slightly less. Okay. And this is the order, I think, Government of India order. This is the order. ISC is under process for making a code. ISC आ जाएगा तो it will be very good. Then disadvantage, advantage तो बोल दिया. Disadvantage, I think some toxic, as he was telling, some toxic present will be there. So toxic gases may come in the road. That may be there. And during the low road laying process, that may release hydrochloric gas. And after laying, it is open that fast rain will trigger leaching. So एक rain के बाद you start using it. So all it will be diluted. Okay. And also you can directly use in the cement kiln. Cement kiln के जो coal चाहिए, coal के साथ ये that also you can use it. That's a good consumption. High quantity. Then plastone. That is just concrete tiles that you are using, that what you call concrete blocks in the pavements, the footpath pavements. Okay. The paver blocks. That paver blocks, that is a very good, you can add these plastics directly by melting. So that can be added in the combination of waste limestone, waste ceramic, waste tray. These are the combinations. And in the total process, there is a carbon dioxide emission. With 1 kg of plastic you are using, 3 kg of carbon dioxide emission is reduced. Okay. And this plastone helps for highways, paver blocks, canal linings. So there was, for every item, there was one slide. I didn't show that. Okay. Just I am listing compound wall, portable walls, lawn floors, brick as load bearers, brick for shock resistance walls, rail sleepers, portable speed breakers, surface modified decorative blocks, tabletops, plastone toilets. So plastone toilet, because this toilet is a margin now, starting from Swachh Bharat completion, that is the main item. So they are making plastic toilets, plastone toilets, sorry, stone plus plastic toilets. These are, all calculation is there. It is very economical. So they are telling whatever funding is coming, you can take another 10 more toilets in that village. Okay. And the price is approximately 10,000. And it is, I think, 2019 calculation. Mane before Corona, all these calculations, all this data we are getting before Corona. Okay. And time of construction is 4 hours. That is the advantage. Okay. And this is all these, how many toilets that target of Prime Minister he has written, he might have written, that is okay. So that can be done, and all the plastic, there is no need of any plastic anywhere. Okay. So this is circular plastic waste management. Okay. So that's all. Thank you.
Sir, so we'll take few questions. So I'll go first then. So, sir, as you say, that we can use plastic in making roads. Even if we do, the issue is what happens when the life cycle of the road ends. Where will we dispose? Because we won't be able to segregate the plastic from
Again,
the
it will
roads.
go to the aggregate now. So that is also circular economy. Roads, roads, actually, you should know concept of the roads. In the roads, there is first one is base, then sub base. Okay. Then subgrade, then subgrade, then there are 4 layers. You go to the bottom layer.
But we can't use the bitumen again now because
Bitumen nahi rahega na. Bitumen cannot be used. But once it is a plus stone, that in the stone, whatever you have used, that aggregate will go to the bottom.
But when it goes to the bottom again, the problem of leaching would be there.
No.
The problem of
Same
leaching.
thing. Actually, how much plastic you can you compare the quantity of plastic and quantity of stone? The stone is 90%, 10% is plastic is there, what I'm telling. But that 10% of plastic will kill all the plastic in the world. So that is the technology. Na? You are using just 10%, maximum 20, you cannot go beyond that. But it helps. That is a water will not go into that. It will, so life will be better like that.
Any more questions? So I guess there are no more questions. So we'll stop for a quick tea break and then we'll assemble here in 15 minutes, right? Thank you.